JProfile has the unique capability to connect JavaScript XHR calls in the browser with a code that handles them in the Java backend. And setting this up is very easy. You just have to install the JProfile Chrome extension from the Chrome Web Store. And in the Chrome browser, you click on the activation icon that is added by the extension. And it asks you if you want to reload the page so you can instrument everything. And it remembers this activation status on a per domain basis. So the next time you come along profiling something on localhost, it will already be recording and you don't have to reload. So here I have this very nice RSS reader. It has a Java backend and an Angular front end. And let's log in and we see the user interface. And when we go back to the JProfile GUI, we see that the help page has disappeared. That informed us about the Chrome extension, and it's asking us to record CPU data so we can see the code that handles the XHR calls in the browser that have already been detected. So the Chrome extension talks to a JProfile GUI on the same local machine without the need to configure any kind of connection. So let's start CPU recording and go to the browser to perform some actions. We could toggle the unread status, change the sort order, look at some feed items, change the layout, mark some feed items as read again. Now obviously all this data that is displayed as a result of my actions comes from the backend. So the front end makes XHR calls to the backend to request data as needed. So let's go back to the JProfile GUI to see what happened there. In the JavaScript XHR view, JProfile has indeed recorded the cumulated call stacks of all those XHR calls. And when we look at that tree, we can see that at the top we have special event nodes that show you where these XHR calls have originated. And JProfile tries to find as much useful information as it can for these events so you can connect them to the actual location in the DOM. This, for example, was when we clicked on a feed item in the compact form of the list in the user interface. And here we can see the event name, we can see the element name, and we can see this Angular specific ngMouseUp attribute. So not all of the XHR calls have an associated parent event, so to speak. They could be called by other mechanisms such as setTimeout. And below the event nodes, here we now have the JavaScript call frames that lead to the JavaScript call frame where the actual XHR call was made. And all these leaves here have these jump to execution site hyperlinks. And those will take you to the Java call tree view, to the actual location where this XHR call was handled. And that is the magic link between the front end and the back end. So let's click on this link to see what happens. In the Java call tree, this is a JavaScript splitting node. And it's conceptually similar to the URL splitting nodes that you see here for the REST interface. The servlet probe splits the call tree for each separate URL so you can analyze the contained call tree separately. The JavaScript splitting node splits the call tree for each different event or JavaScript call stack. So if an event has been detected, you can see the event description here, and otherwise JProfile will show you the last few JavaScript call frames inline. But in any case, you can click on the Show More link to show the node detail dialog, and that displays the entire call stack, starting with the event description and finishing with the JavaScript method that actually made the XHR call. So if it's not your framework that makes the XHR call, but yourself, then you'll be able to see your own code here. In any case, you can see that this is a very useful split, and it allows you to see through your URLs into the browser and focus on the different JavaScript origins that contribute to the CPU load in your server.